This is the second video in our discussion introducing a process to design a misting system. In the first video, we covered step 1, conducting a survey of the property and conceptualizing the path of the nozzle circuit. In this video, we'll cover steps 2 through 5. We also introduced 6 design guidelines to add some flesh to the process. In this video, we will introduce 5 more guidelines. In step 2, you'll identify surfaces that you can use along the nozzle circuit path to install nozzles, and think about how you'll make the transitions from one surface to another, which sometimes requires that you get creative. The most common installation locations fall into 4 general categories: fences or walls, the home or other structures, trees, and in landscaping on risers. Probably the most common installation surfaces are fences or walls. Here are just a few examples. Here the nozzles are installed on a wood privacy fence. Here, on a wrought iron fence. In this photo, they're on a vinyl fence. And here, on a stone wall. Each type of fence or wall presents its own possibilities and challenges with respect to installation technique. We cover some of these as well as specific techniques for other surfaces in other videos in the series. It is also very common to install nozzles on the house or other structures on the property. Here are a few examples where nozzles are attached to structures. Here the nozzles are installed on the eaves. In this photo, they are installed on a screened enclosure around a pool. And here, on the handrail of a deck. If you are considering installing nozzles on or near a structure, think about how easily it will be to clean insecticide residue from the surface, or the consequences of not being able to. Trees are another common installation location. Trees can be an especially useful surface in installing interior nozzles in a large property. Finally, it is very common and popular to install risers in landscaping beds, where the tubing is buried underground and the nozzle is elevated above the ground with copper tubing. Risers are desirable because they keep the mist low and on target. They can also present an installation surface when no other surface is available. An important consideration to make when planning riser installation in a landscaping bed is the potential for phytotoxicity or plant burn. This can usually be managed by avoiding placing the risers too close to plant leaves. If the bed is tall and lush, choose the longer stemmed riser to elevate the nozzle over the landscaping. So use these guidelines as you consider how you'll install a nozzle. Remember, we're trying to avoid drift outside the property. So guideline number 7 is avoid installing nozzles over 10 feet in height, and don't install nozzles on a second story. Wind passing over a fence top creates a low pressure zone that will suck the mist out of the perimeter and off property. So guideline number 8 is avoid placing nozzles at the top of a fence or wall. Instead, try to install nozzles 2 to 3 feet from the top. Guideline number 9 seeks to help you avoid plant burn by placing landscape riser nozzles at least 2 feet from foliage. Now that you've decided where the nozzle should be installed, let's talk transitions. In order to provide coverage throughout a property, most misting system installations will use a variety of surfaces as attachment points for tubing and nozzles. As you follow the nozzle circuit, when the surface changes from one to another, say from an eave to a landscaping bed, you will encounter what we call a transition. At a transition, the tubing will be exposed at ground level, and unless it is protected, it will be vulnerable to line cuts, primarily from weed eaters and animals. This diagram illustrates the most common transitions. In the ground to eave transition here, it is very common to use the backside of a gutter downspout as a way to access the eaves of a house. Be sure to protect the tubing at the transition from the ground to the gutter with conduit. Also use conduit in making ground to tree and ground to fence transitions, as shown here. So guideline number 10 is protect tubing and ground transitions with conduit. Here is a gate on a fence. Nozzle runs on fences are normally very straightforward and relatively simple attachment surfaces. However, you may encounter a gate which must be opened and closed, and you must bury the tubing in the ground below the gate, forming ground to fence transitions on each side of the gate. Now that you've conceptualized the nozzle circuit path and identified specific nozzle locations and transitions, step number 3 is locating an ideal spot for the misting unit. Guideline number 11 says that a location should have the following characteristics. It offers a flat surface for the unit, There is easy access to electricity and water. The unit is accessible for replenishment and maintenance, and the unit is protected from water runoff from the roof and spray from nearby irrigation heads. In most residential installations, the location should probably be pretty obvious. The most common location is next to the pool pump and timer. If you have multiple location options and a large nozzle circuit, try to locate the unit near the middle of the nozzle circuit. This will allow you to engineer your way around pressure drop associated with long nozzle runs, as we discussed in the fundamentals videos. We recommend that as step 4, you create a scaled bird's-eye view drawing consolidating the design. Think about this drawing as a communications tool that you can use to build and communicate a professional proposal, configure an equipment order, plan for other materials or tools you might require, and communicate your plan with your installers. In order to develop a scaled drawing, you need good dimensional information about the property, not to the nearest foot, but probably the nearest 5 feet. The critical measurements are pretty obvious. The outside perimeter of the overall property, the inside perimeter, defined by the house, garage, decks, and patios. You should also take measurements to position the interior structures, like pools and gazebos, inside the overall perimeter. The best way to gather this information is by walking the property with a measuring wheel. For large or commercial properties, you can ask for drawings that may have already been done in support of construction or landscaping projects. You might also be able to gather much of the information you need by finding and measuring the property on Google Earth. The drawing you produce should consolidate your design decisions and depict where you'll place the misting unit, the path of the nozzle circuit, including the length and diameter tubing you plan to use, a precise count of the nozzles on each run and their spacing, normally 10 feet apart but 8 feet apart if the area requires extra treatment, and transitions between installation services. Now that the drawing is complete, let's move to the final step in our process. Since we have a complete count of the number of nozzles on each run in our plan, we will test our design against the pressure and engineering rules that were presented and explained in the fundamentals of misting videos. Rule number 1, about setting the pump pressure, and rule number 2, that defines our target misting zone, are specifications that ensure the installation will be effective and apply to every design. So start by testing your nozzle circuit against rule number 3. Rule number 3 recommends teeing as close as possible to the unit. Does your design do that? If not, is there an opportunity to? Rule number 4 limits the number of nozzles on a single run of 1/4-inch tubing to 35. Do you have any runs that are 35 nozzles or longer? If so, rule number 5 recommends installing a 3/8-inch booster line. Does your design need one? Rule number 6 recommends that you loop the nozzle circuit if you have runs from the unit that are very different in length and nozzle count. Is there a need or opportunity to loop in your design? And rule number 7 recommends using 3/8-inch tubing rather than 1/4-inch tubing if there is a run of 30 feet or more with no nozzles. Does your design require that? If your nozzle circuit design meets rules number 3 through 7, you can be confident that every nozzle will mist within the target misting zone. That winds up our discussion of the system design process. If you follow the 5 steps we've outlined and use the guidelines developed along the way, you should have confidence that your installation will be well designed and effective. You can find a document on the MistAway U Online host site with an outline of the process and a complete list of the guidelines. In the next video in the series, we're going to demonstrate how to apply this planning process in a real-world example.